Howdy folks, this is part 2 on a series of seeing if there's actually any gold in this Colorado gold ore from this gift shop touristy bag. Actually I had 2 bags, I combined them and mixed them up, and I saved some pieces, but there's at least a bag's worth here of that should be a representative sample. So the next thing we want to do is actually crush this up so we can process it further and get the gold out. I'm going to use this pipe rock crusher. I got the idea from YouTube. If you want, go ahead and search YouTube for pipe rock crusher and you'll see a couple of different variations. This is a 1/2 inch pipe by 12 inches with a cap and a T for a handle. I filled it with sand and actually sealed it off with wax to keep the sand in there, and it gives it a little bit more heft. And this is actually an 1.25 inch by 6 inch nipple. I really would have liked to have an 8 inch just to have more room to pound, but they didn't have that at the local hardware. They just had the 6 inch, and they had an 8 inch in galvanized, but I'm going to use this for other analysis sort of applications where I don't want the zinc to get in the way from the galvanizing. And there's a cap on the end of it. I did smooth out the end of the cap. There was some writing and some raised lettering, so I took that off, and I smoothed the inside of the cap too. That was kind of rough. So let's go ahead. I did a little bit of material. We'll do some more, and actually I got to do it all, but I probably won't bore you with the whole process here. But I have a respirator in case it's dusty. And some glasses. Okay, I'll sift it through a strainer just to make sure it's fine enough. And what doesn't pass through, I'll just put back through and smash it up until it's small. Okay, apparently this is not going to be a very fast process. I thought this would work a lot faster. What I'm finding is if you put more than 1 or 2 of these medium-sized rocks, in fact that'd probably be big enough by itself, if you put more than that, it actually forms, it just gets kind of pushed down there and gets plastered against the bottom of the cap here, and it's hard to get out, and it doesn't really crush well. So this is going to take quite a bit longer than I expected, and even if you're a small-scale prospector, this is not going to be really a very valuable tool to process ore. For me, I think I'm going to like it because I do mostly analytical lab work using just, small couple pieces here and there, samples, and it'll keep everything. Usually when I do it, material sometimes flies when I try to break stuff with a hammer or in a mortar and pestle. This will keep it together and should work well for that, but maybe you could use it for some field sampling in the field, just to break up a few rocks and pan some material. But boy, it's kind of a slow go, and you can only do, like I said, one or two small pieces at a time. So anyways, I'll keep at it. It took me about a half an hour or about 25 minutes to run this material through, which was a lot longer than I expected. Like I said, for doing test samples, this is great, but for any sort of small-scale production, forget it. I'll probably run this through one more time and make sure everything goes through the strainer okay. I'm not a prospector, so I don't know how fine I need this. But we'll have it ready to go for the next step of trying to get some gold out of it. I crushed everything up, and I intend to process everything complete, but I do want to just classify it here and just see if there's any color, just out of curiosity. I doubt if there will be, but let's see what we have. I'm not even going to dump anything out. I just want to, like I said, just classify it. This has been kind of sitting here for a while, but we'll try to get it moving again. All right, get it moving around and get the hopefully gold settling on the bottom. So we should have some heavy stuff on the bottom here. I think I got too much water, so I'm going to pour out some of the water. Let's kind of see what's down at the bottom of this. So far nothing that looks like gold, just some shiny bits of who knows what. Getting down to the moment of truth here. Okay, we're down to the nitty-gritty there. I don't see anything. There, like I said, there's some shiny material, but it looks brassy to me rather than gold-like. So, all right, either nothing's here or it's in a different form, and I'm not familiar with these ores, so I'm going to let this dry out and collect it again, and then see if we'll see if we can dissolve anything out of it gold-wise. This is about 2/3 of the crushed ore. I saved about 1/3 of it to maybe try some assay work with it, flame assay, and the rest we're going to try to process with getting it into solution. But I tried to pan and didn't see any color, but that doesn't really mean anything if the gold is locked up in some black sulfide. So we're going to go ahead and roast it, and I'm going to do it with a torch. I don't have an oven, so I'm going to try to be patient. Fortunately, you don't have to get it really hot. Somewhere upwards towards 1,000 degrees Fahrenheit would do it. So this is my roasting pan. It's actually just a tin can that I burned the coating off. It had a lacquer coating on it that lit on fire. I just cut it down and folded over the edge so it's not a cut hazard. So let's go ahead and roast this thing. I do have a fume hood, so that'll take care of the fumes. We'll do it in there. I decided to keep the flame on the bottom so I don't volatilize any gold that may be there, and giving it a stir and checking the temperature, make sure I get it warm enough. I think I'm going to be able to do it, but it'll take a little while to get it done. Checking the temperature with an IR gun, I'm getting somewhere between a little over 700 degrees on the surface, so I think where I'm heating underneath on the can, it's warmer, so I think this is doing an appropriate job. until it was roasted. Checking with the IR gun, the surface temperature got to be about anywhere from 700 to 800, and down at the bottom by the pan where I was heating, it got up to over 900, so probably on average around 800 or so, which I think is warm enough. But I just added some hydrochloric acid to dissolve any acid-soluble material. The gold should not dissolve in plain hydrochloric acid, but this will help get rid of some of the stuff. And it looks like there's a little bit of bubbling in there. I wasn't sure if it was from just air entrapped into the powder, but I think it's actually bubbling. So what I'm going to do now is put this onto a warming plate just to warm it up to speed up the process, and I'll cover it just to keep the fumes in the beaker. So we'll let that sit for a couple hours at least and see what dissolves out of it, and we'll definitely save the solid material, because the gold should not dissolve, so it should be in the solid portion of the material in there. By the color of the solution, it looks like some stuff is dissolving here for sure. Okay, here's the gold ore and acid solution. I'm going to pour off the acid, at least carefully, trying not to get any of the solids down. I'm going to add a little bit of fresh acid and rinse that off a little bit. Here's the last wash with some water, and it looks pretty clear. Okay, I took a little bit of this acid solution that we're using to wash the ore and dissolve the acid-soluble components. Now there shouldn't be gold in here, but I'm going to test it anyways with some stannous chloride solution. So if there's gold in there, we'll see a dark precipitate. Alright, I don't see anything. Looks like it's a lot of iron to me. So let's go ahead and test that. Let's see here. Let's grab some potassium ferrocyanide solution. Which one is that here? See if there's any cupric iron. If this is iron giving it the yellow color, it'll turn a deep blue. Yep, that's a lot of iron that we're dissolving out that you see there. Okay, so far so good. We're dissolving out the other components like iron, but we're leaving the gold in there, if it's there. I did a series of 3 drop tests with ammonium carbonate forming a brown precipitate, ammonium sulfide forming a black precipitate, and potassium iodide kind of turning red. I don't know if that's a precipitate or not. The first 2 are indicative of iron. This last one could be, not sure, mercury, arsenic, copper maybe, not sure. So that's kind of interesting. We will go ahead and try to dissolve the gold with either aqua regia or chlorine.